Okay, so in this video, we're going to talk about polyatomic ions. So far, we've just talked about monatomic ions. Those are just, elements with made up of one, or ions made up of one type of element with a charge. For example, chlorine is just one element and it has a, -1 charge. That is the chloride ion. All right, so now we're going to talk about something a little different. Now, a polyatomic ion is a group of atoms with a charge. And if you look, there's examples here. These are the ones that I want you to learn. Now, you have a handout with a list of these that I want you to cut out and glue it or tape it to the back of the periodic table that you keep in your notebook. That way you'll have it to use on these problems we're going to do, and you'll have it to use on the test. Otherwise, you'd have to memorize these. In normal years, we would memorize these ions and we'd actually add some more to this list, but because of time and we have this 9 weeks is about a week short, I'm not going to make you memorize these this year. Now, these are examples of polyatomic ions, and NH4 plus 1 is called the ammonium ion. If you notice, it's the only positive ion that's a polyatomic ion. It is a cation. All right, so it will act kind of like a metal when it reacts with a non-metal or another polyatomic ion. Now these other ones, carbonate, CO3, -2. The formula is CO3, and the charge of it's -2, which means that it's like a compound that has a charge. Compounds are normally neutral. This is like a compound with a charge, and it needs 2 electrons to be stable, and it's going to get that from a metal. All right, hydroxide is OH minus 1. OH is the formula, -1 is the charge. NO2 minus 1 is nitrite. NO3 minus 1 is nitrate. Make sure you don't get those two mixed up. Remember the formula for nitrites, NO2, nitrates, NO3. Sulfite is SO3, and it's a -2. That's its formula. SO4, and it's a -2. That's sulfate. So make sure you don't get those mixed up. And then PO4 -3 is phosphate. So, for example, if we had a nitrogen atom, this is like ammonium, and it's bonded to 4 hydrogens. That would be NH4, and it's an ion, it would have a +1 charge. So it could react. It couldn't react with other metals. That it acts as a cation. It's only going to react with other nonmetals. It might react with a chlorine ion. If you had a chlorine, also a -1 charge. Well, if you write the formula for that, it would form a compound. Now, how could I tell if an element or a formula has a polyatomic ion in it? Well, if you look, let's see if we have an example. If you notice, there's 3 elements that make this compound up. You have sodium, Na, S is sulfur, and O is oxygen. If something has 3 elements in it, then in our examples, it's going to have a polyatomic ion. All of our other compounds were binary compounds made up of 2 elements. These are what's called ternary compounds made up of 3 elements. And more than likely, on examples where there are 3 elements in a compound, it's going to be polyatomic. There's going to be a polyatomic ion somewhere in there. And 90% of the time, it's going to be the last 2 elements, because most of our polyatomic ions have a negative charge, the anion, and the anion's always, comes at the end of a formula. And, there's only one positive ion that's going to come at the beginning. You might have like NH4Cl. That would be the only examples where NH4 is used, where it's used as a cation and it's at the first of the formula. More likely, the last 2 elements are going to be a polyatomic, and we'll use that when we name those. and when we write formulas. Now, if you notice on our list here of 8 polyatomic ions, there's only one of them that ends in IDE. You know the rules for naming binary compounds is whenever the second element, you drop the ending at IDE. Well, when we name these name compounds that have polyatomic ions, we will not drop the ending at IDE. We'll leave it the name that it is. And, hydroxide is the only one that ends in IDE. Now, when hydrogen forms an ion, like H-1, it becomes hydride. That's a difference than OH minus 1, which is hydroxide. So don't get those two confused. All right, so if we look at our first example, we're going to look at naming polyatomic ionic compounds, ones that are made up of 3 elements, and then in some examples it might be 4 if it's 2 polyatomic ions bonded together. If we look, first step in naming, even before name the metal or cation, is determine if it's ionic or covalent. I look at the first element, it's calcium. Calcium's in group 2A. It is to the left of the stair-step line, so it's a metal. So I know I got an ionic compound. My next step should be and say, well, do I have a binary compound that's made up of 2 elements, or do I have a polyatomic ion? And if you see parentheses, especially in a formula, that ought to tell you right there that's a polyatomic ion. There's a certain reason we have to put those in parentheses sometimes, but not all the time. But I want to look and see if it's made up of 3 elements, then I know I got a polyatomic ion. So first I'm going to name the metal or the cation. So that is calcium, Ca. And then I'm going to name the polyatomic ion. Do not change the name of the polyatomic ion by dropping the ending. We only do that for binary compounds, not for these with 3 elements in it. So if I look up on my, your lists, you should have them taped to the back of your periodic table. If I look back at my list and see, OH, what is the name of that ion? And OH is the hydroxide ion, so I'm going to write out the whole name of it, calcium hydroxide. Now, looking at some more examples. First, I determine is it ionic or covalent. Zn is a metal. All right, and then I determine is it binary, does it have a polyatomic ion? What has Zn, zinc, sulfur, and oxygen, so it's got 3 elements. It's got to be a polyatomic ion in there. And I notice that the last SO3 is a polyatomic ion. So when I name this, I name the metal zinc. Then I name the polyatomic ion. SO3, if I look at my chart, it is the sulfite ion. And that's all there is to it. Don't change anything in the name. Look at the next example. MgNO3, 2. First element is a metal, so it says ionic. It's got 3 elements in it. Magnesium, nitrogen, and oxygen, so it's got to have a polyatomic ion, and it's in parentheses there. So I named the metal magnesium. I look up the formula. What has the formula of NO3? The 2 just tells me, that 2 on the outside just tells me that I have 2 of these NO3 ions. Alright, so don't worry about that 2. Just look at what's in the formula there. NO3 is the nitrate ion. Okay, next example. I have NH4 with a 3 on the outside and PO4. That 3 on the outside is just telling me that I have 3 NH4 ions. Alright, so I look, and if I notice, I got 4 elements that make this up. If I have 4 elements to make it up, more likely they're both polyatomic ions. So I have to name NH4. That is the ammonium ion. And then PO4 is an ion. I look it up on my chart, it's the phosphate ion. Alright, then our last example. I have NH4Cl. And remember, I told you, it has 3 elements in it. I look at the first, even though the first element's a non-metal, it isn't covalent because, I look, it has 3 elements in it, and it's ionic. NH4 is a polyatomic ion. Most time it's going to be the last 2 elements in the compound that's polyatomic, and this time it's the first 2. NH4 is the ammonium ion. And if I look, the second element is Cl. All right, it's a single element. So when I write it, chlorine becomes chloride. I would add the IDE because it's a single element, not a polyatomic. Now let's look at writing formulas for polyatomic ionic compounds. First example, and again, when we write any formulas, we need to determine if it's ionic or covalent first, because these are all going to get mixed up in worksheets from now on, and when you have quizzes too. So when you get in the habit of checking. I look, magnesium, metal or non-metal, it's in group 2A, so it's a metal to the left of the stair-step line. And I look in the second element, the second thing mentioned here is carbonate. Since it doesn't end in IDE, I know for sure that it's telling me it's a polyatomic ion. So I'm going to write formulas for the metal cation and polyatomic anion, including charges. Magnesium, I look at the charts in group 2A. I know magnesium always forms a +2 charge. And then I look, the polyatomic ion, I got to go and I got to get the formula from my list. If I look at carbonate, I see that it is CO3 and it has a -2 charge. All right, so when I write this formula, I'm going to check see if the charges are balanced or they add up to 0. Does +2 plus -2 equals 0? So it does. And if it does, I just cancel out these and write the formula. It's going to take just 1 atom of magnesium and 1 ion of carbonate to balance this charge. So this would be the correct formula. Okay, another example, zinc hydroxide. It says check see if the charges are balanced or after 0. And after I write the formulas, I have Zn. And Zn is one of our transition metals that has a definite oxidation number or charge that you need to memorize or have written down. Zinc is always a +2. All right, and then hydroxide, I look, even though it ends in IDE, you just have to memorize that one polyatomic ion ends in IDE, it's hydroxide, and you're just going to have to remember that. It's not talking about a single element in this case. It's talking about the polyatomic ion, OH, and it has a -1 charge, meaning it needs 1 electron to be stable. All right, so if they don't add up to 0, which they don't, +2 plus -1 equals +1. I got to cross my oxidation numbers and write them as subscripts. Use parentheses around the polyatomic ion if you need more than one of the polyatomic ion. So basically, I can do this one of 2 ways. I can say, well, I got a +2 here, a -1 here, and obviously I need another one of these ions to balance the charge, because this would add up to -2. This equals +2, and that would add up to 0. So when I write my formula, it would be Zn. And then since there's more than one of these ions, I need to put the formula in parentheses and put the 2 on the outside, showing that I have 2 of these ions. If I wrote this as like this, it would be wrong. Reason being, if you look at the top example here, you have 1 zinc, you have this number on the outside of parentheses goes with everything on the inside. So that means you have 2 oxygens, 2 hydrogens. When you write it like this, you have 1 zinc, 1 oxygen, and 2 hydrogens. That's a different compound. That's not the same thing, so it would be wrong. Now I also could do this where I cross my charges if that's the way you choose to work them. Or I'm going to bring the mark out my plus and minus. Don't need those. I'm just going to bring these down here. Bring the 1 down here. That'd be Zn. I only need one of those. I don't have to put the 1, it's understood. And I have OH, but since I'm going to have a 2 coming down there, I need to put it in parentheses and put the 2 on the outside. Okay, next examples. If I have nickel 3 sulfide. Now the 3 here is telling me the oxidation number of the metal. You know, it's a positive 3. It doesn't tell me I have 3 nickel atoms. It just tells me that nickel in this case is a positive 3. It's giving up 3 electrons. So I write my symbols. Nickel is a positive 3. Sulfite. I notice that ITE must be dealing with a polyatomic ion. I look up the formula. Sulfite is SO3. It's minus 2. Now, the first way is just whichever way you choose to work these. But the first way, if I was going to balance these charges, I would need both. I'd do the least common multiple of 3 and 2, which is 6. Meaning I need a positive 6 overall here and negative 6 overall here. So that means I would have to have another nickel for sulfite to equal negative 6. I would need 2 more of those. SO3 minus 2, SO3 minus 2. Now all those add up to 0. And I'll write my formula. That means Ni2 parentheses, because I'm going to have more than one SO3s. I'll put SO3 and then a 3 on the outside. And that would be the correct formula. Now if you do it the other way, then I'm going to cross my charges, leave the plus and minus up, don't mess with it. Bring the 3 here, the 2 here, and write my formula. Ni2, written as a subscript, tell me I need 2 nickel atoms, and SO3. Because look, if I didn't use parentheses, this is what I'd end up with. SO3, SO33. I mean, I have 33 oxygen atoms. I don't know, that doesn't make sense, so I put parentheses around the formula of the ion. Okay, next example, ammonium phosphate. Ammonium, you have to recognize, remember, that is a polyatomic ion. I look up it's NH4, and it's a positive 1. Phosphate, look it up, it's PO4, and it's a minus 3. So, to balance out the charges, you know, this needs to be a negative 3, this needs to be a positive 3 to make them add up to 0. So I would need to add 2 more of these ammonium ions, and I would only need 1 PO4. So when I write this, since I got more than one of these, I put the parentheses on the outside, NH4, the formula of the ion on the inside, number of many I would need on the outside, which is 3, and then PO4. And since PO4, I only need 1 of those, I would not put it in parentheses. I mean, I see some people that do that, that put every polyatomic ion in parentheses. There's nothing wrong with that if that helps you to do that. But, you know, answers on a test, if I have multiple choice, I won't have that in parentheses. PO4 just means that they are one of those ions. Now, if I was going to do the other method, crossing my charges, since they don't add up to 0, leave the positive and negative, bring 1 down here, 3 down here, and I would write my formula. NH4, if I didn't put it in parentheses, it would be NH43, which would make sense. Put the 3 on the outside, and PO4. And the 1 goes down there, but it's understood. You don't write the 1 down. Now, beryllium nitrate. Beryllium is a metal. Nitrate, I recognize as a polyatomic ion because it doesn't end in IDE, and it's not, you know, unless it's hydroxide. So beryllium is in group 2A, so it's a positive 2. Nitrate, if I look on my list, it's NO3, and it's a -1. So I need these charges to equal 0. So I'm going to need this to equal -2 and this to equal +2. I don't need any more berylliums. I have enough. But I do need one more of these ions. -1 plus -1 equals -2. +2 plus -2 equals 0. So I write my formula. It's going to be Be1. And then NO3, since I need more than one of those, put in parentheses the NO3 and put the 2 on the outside. Or if I do it the other way, bring just my numbers down, bring the 2 down here, bring the 1 down here, that'd be Be1, which if I leave the 1 out, NO3, since I'm bringing a 2 down, I need to put the NO3 in parentheses and write the 2 on the outside. Either way you do it's fine. Okay, so in these practice problems, the first ones you're going to be naming these, and then on the next ones you're going to be writing formulas. After you get through with these, you can check your answers with the PowerPoint.